Hello class, this is a video tutorial on the commutative property of transformations, part 2. In the previous video on this topic, we saw how any two translations are commutative, even if it's two horizontal, two vertical, or one of each, one vertical and one horizontal. And if you switch these around, it doesn't matter what order they're done in, any two translations are commutative. In this video, we're going to look at the proof that any two dilations are also commutative as long as they are on different axes. Meaning, if we dilate on the horizontal and then dilate on the vertical, it will be the same as if we dilate on the vertical and then dilate on the horizontal. So let's do a proof of this. Let's do this on the function f of x squared minus 6x plus 8. With any sort of question like this, it's always best to factorize the numbers that we have. So this will factor into x minus 2, x minus 4. Okay, and this is going to be the function that we're going to be using to prove this commutative nature of two dilations of different axes. So let's take a look. Just so long as we remember, a horizontal dilation, we replace x with x over h, meaning a factor of h. And for a vertical dilation, we replace y with a factor of y over k. Okay, so and to prove this, let's do a horizontal dilation of, let's say, 2, and a vertical dilation of 3. Okay, and let's see what this will look like on our function. So here's our function. Y is equal to x minus 2, x minus 4. So let's do the horizontal dilation first. Let's replace everything with x over 2. This will give us y is equal to x over 2 minus 2, x over 2 minus 4. Collecting like terms, or just multiplying these out by 2, or factoring out a half on each, we will get half x minus, this will be 4, and for this one it will be times half x minus 8. Overall, this will give us 1/4 x minus 4, x minus 8. And now if we dilate on the vertical axis, we're going to replace y with y over k, in this case by a factor of 3. So we're replacing this with y over 3. So y is now going to be y over 3 equal to 1/4 x minus 8. Multiplying everything by 3, we get y is equal to 3/4. I'm going to copy the previous line here. So that's what happens if we dilate horizontally and then vertically. So let's take a look at what happens if we do this in the other order. So let's do the vertical dilation first. Let's replace y over 3. So here's our function again. Y equals x minus 2, x minus 4. And let's replace y with our dilation of 3. So y is now going to be y over 3 is equal to Let's multiply everything by 3, giving us 3x minus 2, x minus 4. And now, if we apply our horizontal dilation by replacing x over 2, we will get 3x over 2 minus 2, x over 2 minus 4. Factoring each of these, we get 3 times, going to factor out a half from here, so half, x minus 4 times, factoring a half from here, x minus 8. Collecting all not collecting all like terms, sorry, we're evaluating all the values. 3 times half gives us 3/4, x minus 4, x minus 8. As you can see, they give us the same result, which proves that a dilation on opposite axes or on different axes are commutative. You can try this with any other function and any other dilation values, and you'll find that they are also commutative, so long as, once again, the dilations are on different axes. So one horizontal, then vertical, or one vertical and then horizontal. Hope to see you in the next video. Best of luck.